So in this video we're going to be talking about completing the square. And completing the square is one of the things that math teachers and tutors tend to skip over a lot. It's in the book, it's in the packets, it's part of our curriculum, but we tend to gloss over it. What usually happens, in my experience, is that once a student learns how to use the quadratic formula, they use it to solve everything that they possibly can. Anything that requires them to solve an equation or generate the roots or find the x-intercepts, they will quadratic formula that. And they won't use complete the square unless specifically told to. And even then, if they think they can get away with it, they'll still use quadratic formula instead. And to be honest, that really is setting our students up to fail. We're moving more and more towards all of our students taking Algebra 2. Our math students in Algebra 2 currently, they've been increasing for the last several months, and it's expected to continue to increase. So it's really important for us to know how to complete the square so that we can teach it effectively. And to be honest, there's really no reason to be intimidated. Completing the square is actually about the same amount of work as quadratic formula is anyway, and it's only 5 steps. It may take a few tries for students to master it, and it's true they do have trouble remembering it, but it really isn't that hard. There's no reason to be intimidated. So I have a couple of examples here, and we're just going to work through the steps and see what we get. So when you're completing the square, your first step is always to move the constant. So in this example, obviously our constant is 3, so we're going to add 3 to both sides of our equations, giving us x squared minus 6x equals 3. And notice I left a little bit of space there. All right, that's going to come in handy. Now, one of our most common errors our students make is that when they go to dividing, they try to divide this 6 out. All right, they're going to say divide by 2 right there. Don't let them do that. All right, make sure that they rewrite the 6 under the problem and divide by 2 right there, giving them 3, and they can square it, giving them 9. And they can add that 9 to both sides. And I know some of you at home are keeping track or going, hey, Matt, what about the leading coefficient? You completely skipped number 2. Well, leading coefficient here is 1. And as we all know, if you divide by 1, nothing happens. So long as there is no a term, there's no coefficient in front of your x squared term, it is safe to skip this step every time. For those of you whose students are really particular about doing things the same way every time, go ahead as a form, have them divide it out if that makes them more comfortable. But it really isn't. It isn't necessary. This is necessary. Make sure they write the 6, whatever their x term is, underneath the problem so that they can divide it and work this math out. Every single one of them is going to try and do the division right here and then square and add in their head every single time. And that will give them the wrong answer about 3/4 of the time. Make sure that they follow this step. Okay, it is important. So now we can simplify. Right, we did our division and we added. Now we're going to simplify. This side equals 12. And over here, you notice that this is now a perfect trinomial square. All right, and that is really the entire point of completing the square. It takes something that would not ordinarily factor and makes it factor so that you can rewrite it. Okay. It is always going to be the first term, the first sign, and the square root of the last number, which you notice is right here. They can just drop it down. Okay, that's one of the reasons why you have it right that way. So now, that's it. We have completed the square here. If we still need to solve, it's a simple process of square rooting both sides to cancel out your exponent, giving you x minus 3 equals plus or minus radical 12. 12 obviously does not have a square root, but we can put that in simplest radical form by prime factoring that into 4 and 3. And 4 has a square root of 2. Right. And as a last step, to get x by itself, we would add the 3 to the other side, giving us x equals 3 plus or minus 2 radical 3, which you will note is the same answer you would have gotten from quadratic formula anyway. Quadratic formula is typically about 5 steps. To work it all the way out, you notice it says it is 1, 2, 3, 4, 5 steps. It is actually the same amount of work. So there's really no reason to be intimidated by this.